Hello everyone, it's Mr. Canfield. It's time for Chapter 3 in Algebra 1. Alright, so it says 3-1, lesson assignment, assignment, that's what I wrote. So watch the video while you're working through this. So what you're going to want to do is you're going to want to go to Savas, you're going to want to find this assignment, you're going to want to open it up, and your problems are going to look a little bit different than mine, but we're going to be able to talk through and figure out how to do the assignment by watching me do it. And as I do a problem, you can do a problem. And anytime you learn something new, that's what notes are for. So we're going to go in and we're going to write some notes about it. So you might notice I'm using a slightly different setup from last time. So I'm sure there'll be a couple of hiccups here and there, but by and large this should run a little bit more smoothly, which makes me happy. Ooh, that poor happy face. All right. So again, if you're with me, all you got to do is go into the assignment. And remember, you're watching a video. I'm doing preview. You should actually do the assignment. But you can pause this video anytime you want, and you can rewind and check something again. So here we go. All right. So use the graph to determine the domain and range. Then state whether the relation is a function. So this first question says, what is the domain of the function? And you might notice, if you saw what mine was previously, it's the same kind of shape, but it's moved around to a different spot. So domain and range is pretty simple. I'm just going to copy the picture over here. Domain is, if we're going to speak really mathematically, domain is all the x values that this function has. And in case it's not super clear, this function is this like pink, fuchsia? I don't know what color that is. It's not red, green, or blue or yellow. So this like pinkish line curvy thing here, domain is all the x values that it is. So if we look on here, we can say, all right, well, what x values is it? Let's see, I see the x value -4, and what I mean is, we have a bunch of points, right? I've got -4, and then looks like my y value is -1 there, and that's that point right there. And I can go through and I could list all these points, but the problem is, what about -3.9? If I'm going to try to list all the x values, I have to list -3.9. I have to whoa, there's something in between -4 and -3.9, like -3.91. Shoot, wait, this is too many points. So there's actually a better way than listing out all the points. What we do is we give the range of the values. So the domain is all the x values that it is. So the simplest way that we do it is we look all the way to the left. So if I look all the way to the left, that's here. What x value is that? So I look all the way to the left. Oh, it's -4. And then I go all the way to the right. Does it stop anywhere? Is it missing anywhere? No, we fill in every spot between here and there. We do have an x value. So you could even, yeah. So if we look at this line as it moves, there's always the function there. So what we can do is we can say it goes everywhere from -4 all the way up to wherever it ends, here at the right. So what's that? Well, let's see. Stops right here when x is 2. So it says type your answer in interval notation. So this is it's a fancy way that we type this, but what we're going to do is we're going to say, watch what I type before I type it. We're going from -4 all the way up to 2. So we start at -4, we end at 2, and as long as it's got these closed dots on the ends, we use a bracket, which, let's see, the bracket is, I think I'm too zoomed in. Let's see. the bracket, the bracket, the bracket, the bracket. Aha. Wait, here's a parentheses. We don't want parentheses though. Oh, here it is. We want this guy, this bracket. Okay, so what I'll do is at the beginning I'll put a bracket, and at the end I'll put a bracket. And that's how we say domain in interval notation. So this isn't the point -4, 2. This is saying domain goes from -4 to 2. And that's what we want. Now, range. Range is going to be the same idea, except instead of going from left to right, we go from down to up. So what is the downest this gets? All right, I'll stop using silly language. What's the lowest this gets? We look for the lowest y value, and we look for the highest y value. Whatever those are, that's going to be our range. So if we look over here on our graph, for mine, looks like the lowest y value I see is -4. Oh, that's convenient. So I'll use this bracket guy again, and I'll say -4, comma, and then what's the highest it gets? Looks like the highest it gets is right down here, and if I'm careful and read my scale, that's at -1 on my scale. It's going to be different on yours. But it says every y value between -4 and -1. Also, on your keyboard, your actual keyboard, right above the Enter key, you might notice that the brackets are actually there. So you can just use your keyboard to do that. You don't need to use the show more thing. Is the relation a function? Okay, so we haven't talked about that. We've talked about domain, we've talked about range. Now we're going to talk about what a function is when we look at a graph. So functions, that's not the color I want. Functions are another way of us saying that on some graph, for any x value that we have, we're only ever going to have one output. So you know what, I should write about these things. Let's make this font a little smaller. Okay, so domain all the x values of a let's see, I'll just make this big really quick. All the x values of a relation, range, if I'm going to capitalize, I should capitalize that one too. Domain, all the y values of a relation. I guess we should define what a relation is. A relation is any collection, and this isn't the math version, any collection of x and y points. So relations are any group of points. So you can even say any group, if that's a better word, any group of x, y points. So if you want to write it like that, you can do that. The reason why I'm not giving you the straight up like this is the math definition is because so many times people get confused by the official math definitions. I'm trying to give you common English ways to think about this. So we'll talk more about interval notation. That was the way that we wrote our answer. We'll talk more about that as we go. But we got relation, we got domain, we got range. These are words that we're going to use a lot in here, so make sure that you've learned them. Relation, not so much, because the big one that we care about is function. So functions and what they are, they're relations where each x never has more than one y. So each x never has more than one y. So that's what a function is, and that's the specific like the more selective group of relations. So like relations are, I like to say relations are everything. So like let me show you some examples of relations right now. If we were in class, I'd be like, all right, just let me know, is this a relation or is it not a relation? Like, and that we would just, you just be kind of yelling it out in class. But since we're not in class, just pretend. And you don't have to say it out loud. Oh no, I'm going to ask your parents, hi, did your kids like shout out loud at one point? Yes, no, yes, no. All right, so here's our little coordinate plane. All right, question time. Is this a relation? Yes, everything's a relation. Is this a relation? Yes, everything's a relation. Is this a relation? Yes, everything's a relation. You're doing great so far. If your answers have all been yes, yep. How about this? Is this a relation? Yeah, that's a relation. Then the best one, is this a relation? Yes, of course it's a relation. Everything's a relation. So you might be like, well, why do we even bother having the word relation? Well, it's the same thing like we're animals, our pets are animals. Animals is like the big broad term that they use for all these different kinds of animals. Relation is like the big broad term that we use for all these different kinds of graphs. So so in general, if somebody says, hey, is this a relation in math? Yes, the answer is yes. Okay. I think a good question that some of you might have is there anything that ever isn't a relation? And with what we deal with, no, that's never going to be the case. So don't worry about that. Everything's a relation ever in this class. Okay, function. Relations where each x never has more than one y. So that's when we go through and we can say, okay, something like this. This is a relation, but is it a function? And what that means is if I wrote out a list of all the xy points, so like let's say this one was 2, 5, right? When x is 2, y is 5. What makes this a function is that 2, that x value, gets 5, that y value. Does 2, this x value, ever get any other y value? And you might be like, that's a weird question. Like, look along here. Are there any other y values except for 5 when x is 2? No, it's just 5. So, and this actually is the test that we do. There's a check that we do. It's called the vertical line test. And we just go in, and we draw a bunch of vertical lines, and we ask ourselves, hey, do these lines ever touch more than once? If they ever touch more than once, that thing is not a function. So let's draw another relation in here. If you're like, why are you just undoing? Yeah, it's almost there. All right, here's our next function. All right, so if I go in and I draw my vertical lines, is this relation a function? Oh, there it gets close, but we're just going to assume that that didn't actually hit. Cool, that relation's a function too. So what about this one? Well, over here, it's not hitting more than once, but then right here, hit, hit, hit. That hit more than once. That means this is not a function. Let's look at something else that's not a function. This is not a function. Because you can draw a line through it, a vertical line through it, and it hits more than once. And this is called the vertical line test. This is the official name for it. I'm confused. I'm clicking text. Oh, do I have to click that? There we go. So this is a big deal. Vertical line test. If you draw a vertical line through a relation and it never touches more than once, the relation is a... Now let's see if I can spell without looking at it. Okay, let's see if I spelled it right. If you draw a vertical line through a relation and it never touches more than once, the relation is a function. Ooh, that's super messy. The short version is draw vertical lines, that's this way, as long as they hit at most once, we're good. So if you haven't already, I recommend writing these things down. You know, we've been that was not on purpose. Okay. So you can always pause and go back. I'm just going to retype it for my own sanity here. Vertical line test. I'm still struggling writing the word test for some reason. Vertical line test. If you can draw vertical lines and never hit it more than once, it's a function. Woo! All right, so let's look at this problem and see if it's a function. Okay, so all the groundwork's been laid. All we have to do now is look at this picture and ask ourselves, is this relation, which is anything, is this thing a function? So we just got to go, hey, can I draw vertical lines, and do those lines ever touch it more than once? Nope, they don't. Once or none. So we're good. Wait, that's a final check? Is it just because it took too long? Anyway, let's see. If the, oh boy. Oh, right. I put this question on here so that I could talk about it. If I just gave this to you guys as a homework question, I think it'd be a little bit mean because there's a lot of words. But let's just select. Let's just select this stuff here and shrink it down just so we've got it. All right. If the domain of a relation is all the whole numbers between 2.5 and 7.5. So let's talk about what that would mean. So the domain said the domain was all the whole numbers between 2.5 and 7.5. But let's think about this on a number line, right? Here's 2.5. Here's 7.5. So this is going to wind up being a list of numbers, and the way that we list a number is we use curly braces. That's on the same key as the bracket in our computer. It's the one that kind of looks like a sideways seagull. So it says whole numbers between these two. Well, what's a whole number between them? Well, if I go along the number line, 3 is a whole number between them. And then we hit 4. And then we hit 5, and you see that my scale's really bad. And then we hit 6. Oh, wait, we also hit 7, don't we? My scale actually was okay. So 3, 4, 5, 6, and 7. So that's the domain of this relation. And the range contains 6 different values. Can you determine whether the relation is a function? Explain your reasoning. So this comes down to, this is a new idea. This is a fancy question. The range is going to be, we don't know, but it's going to be like A, B, C, D, E, let's see, 1, 2, 3, 4, 5, F, right? So the idea is, when we're looking at this, are we able to determine whether or not the relation is a function? So my gut reaction says no, and the reason why is we don't know how many times 3 shows up. We don't know how many times 4 shows up. Basically, when we're looking at these, domain was our x, range was our y. Domains are only ever allowed to show up one time. X's can only ever show up once. If they ever show up more than once, that's a pretty good indicator that that we've got a problem. But like we can make points out of these. Like we can make 3 comma a, or we could make 3 comma d, or we could make 4 comma c, or 7 comma a. Like picking one of these for the x and one of these for the y. So let's see. The domain has many values as the range. Has as many values as the range. Does it? I only got 5 here. Did I miss one? I don't think so. The domain has more values than the range. No, I think the domain has fewer values than the range. So there must be a domain value which maps to more than... Oh, right. Okay, let's look at that. So if we look at our different like points that we could make, and we just kind of do a hypothetical here. I'll do hypothetical really light here. I can match 3 with one of these, right? So let's say I match 3 with A, and then I match 4 with B. You know, just keeping it real simple. Matching 5 with C, 6 with D, 7 with E. The problem is, who gets matched with F? And so one of those is going to have to get matched with F. And since one of those is going to get matched with F, that means we're going to have one of these that has to show up again. That was a tricky question. All right, so I think there are more questions that are going to talk about this. So if that was kind of iffy for you, don't worry too much about it. Here we go. Describe 2 different representations that show a relation is also a function. So a graph represents a relation. It's also a function. Okay, so if we want something to be a function, each x never has more than one y, right? We wrote that down. If and only if every... Oh, curve, straight line. Wait. Oh, we had the vertical line test, right? How many times are we allowed to touch? Is it exactly once? Oh, wait, no, it's not exactly once, right? Didn't we say it never hit more than once? It never hit more than once. So we could say never hit more than once, no more than once. All right, so what about a table? Now, we didn't really talk about a table. So this that I was kind of drawing on over here, this kind of starts to look like a table, but it's not really a table. So let's shrink this down. We might need to come back to that later. But you know, if we look at a table, oh no, I don't have a nice way to make tables on this, do I? Oh, I'll just do a makeshift table. Yeah, we can do that. All right, so let's say we've got your table. Boom, boom. So we have our XY table, right? So if we have 3 and then 4, just understand that's meaning the point 3 comma 4, right? 2 different ways to write the same thing. So a table represents a function. So when we talked about a graph, the idea of a graph was that you never had a place where there's one point and then another point. So let's talk about this point. If this was at the x value -2, this would be like -2 comma 2, right? If we said this was 2 right here, and let's say this is like 3. Now we have -2 comma 3. So visually we can say this isn't a function because it fails the vertical line test, right? Like hits it twice. But what does that mean for a table? Well, that would mean that on a table, I couldn't have something like this. And I was mentioning this a couple minutes ago. See how -2 repeats itself in the x? That's bad. So, oh yeah, x's we call inputs. So every input is, I think it's every exactly one output. Okay. So this diagram, all right, this is another example of inputs and outputs of x's and y's. So, am I screen capturing everything? Okay. Earlier I tried to make this fancier and it didn't work. All right, so where'd it go? Where'd you go? Don't leave me. No. All right, let me zoom back out. And now I have to go find it. There it is. Okay. All right, bottom left. There we go. Okay. So let's talk about what we have here. These are our x's, right? And these are our y's. So then this means that we have 22, 22 comma 19, right? That's one of our pairs. Then 20 comma 2, and then 17 comma 19. Is this okay? Well, yeah, because the x's aren't repeating. So the domain, oh, I'm getting ahead of myself, aren't I? It just wants to know the domain. The domain, we normally list the domain in, I almost said alphabetical order, ascending order, or increasing order. Domain is ridiculously easy if you remember that domain is x. Range is y, right? I'm going to see if it marks me wrong for putting it in backwards order. Oh, they don't care. Cool. That's good to know. I want to try another one. I'm going to try writing the domain in some silly order this time. Will they take 14, comma 13, comma 8? Just in a completely mangled order. They do. Good, good. So I don't like to take off points if you don't write it in order, but you know it's good to write it in order, in increasing order. All right. What's the domain of this? Well, domain is just going to be our x's, right? Alex and Angela and Trent and Anne and Maria and Peter. Let's see. All the names, right? And then what's the range? It's going to be all the dates, right? So this one looks like it's all of them. All right. Analyze the situation. Identify a reasonable domain and range for the situation. All right, let's see. So this is why I called this like a lesson assignment. I don't know. Lesson assignment. Oh, it's right there. L'assignment. Because I'm not asking you to do this on your own. I want you to think about it with me. So the distance an airplane has traveled at any point during a flight is determined by the airplane's speed, 565 miles an hour. So the domain, oh, we're trying to find numbers that would make sense. So what would be an input here? The input would be any point during the flight. So that's going to be something, that's going to be talking about time, right? So, you know, if we were going to write some kind of equation for this, one that we commonly see, whoa, let's try that again. One that we commonly see is distance is equal to rate times time, right? So distance, we would say distance is a function of time, and rate is constant here. It's a little bit too much. Okay. So our independent variable, or our input here, is going to be like, well, hey, how far am I? Well, I know my equation. What time is it? If I know how long I've been going, I know how far I've gone. So our domain, we could say any number we want. So that's all real numbers, but negative numbers don't make sense, right? And we don't know how long this flight is. So I'm going to say all real numbers greater than or equal to 0. Because we don't know if this flight takes 2 minutes, we don't know if it takes 20 hours, we don't know if it takes 365 billion years. That's the thing about mathematical models, is sometimes they're not realistic after a certain point, but this one we could say, well, let's start at time 0, that's the start of the flight, and then go till it's over, but they didn't tell me about when it's over. Let me just make sure. Oh, they do. All real numbers from 0 to the duration of the flight in hours. So we don't know how long that is, but it's there. And then the range, well, let's see. Would the range just be all the whole numbers? So 0, 1, 2, 3, 4, 5. Well, this could be a whole bunch of different things. So it's not even going to be integers, which is, integers are just like whole numbers, except you also have negatives. And then let's see. Range, well, if I drive for 5 hours, that doesn't mean that I went 5 miles. So we can't say that the range is going to be, we could say that the range is going to be 0 to how far the plane goes, right? So that's going to be that one. So if I went 5 hours, it's going to be, well, I went 565 miles an hour, so it's going to be 565 times 5. So however long the flight is, we'll do that times 5. I didn't want to include those questions, but I thought it would be good to have some word problems and talk through at least a little bit. All right. So we actually are almost done, believe it or not, even though we're only on question 7. All right. So we got this one here. Is it a function? It misses here, but that's okay. And these, although they look like they're straight up and down, they're not actually straight up and down. There's still curvature to them. So yes, this is a function. Next one. Man, I'm getting final checks for all. Oh, because it's a yes or no. That's why it's final check. Is this a function? Well, same deal, right? You can draw vertical lines through it. It never hits more than once. So yeah, we're good. I want to see what a similar question looks like. Pfft, silly. This one. Excuse me. Let me get this. All right. So do you see it? Draw your vertical lines. Oh, I mean, if you draw it like right on the edge, it only hits it once. You know, like we call that like a tangent line. Okay, but then right here, hits twice. So not allowed to hit twice. Therefore, not a function. Let's see what another one looks like. Ooh, that one's like a circle. Same deal, right? Then we got this one. Oh. So again, like over here on the edge, we could say that's like a tangent line, but then it's going to hit twice right there. Let's see what's next. And you thought I wasn't kidding when you thought I was serious, or nope. And you thought I was wrong when I said we're almost done. We are actually almost done. All right, correct domain. All right, look at this. This looks weird, right? If you hear Maeve in the background, she is just playing. She's at the age where grunting is fun to do. And yelling. All right, so if we're going to talk about the domain for this, this right here is just saying domain is X. And that little bar is just blocking it off. So let's see. It's either 4 or -4. Well, let's see. Domain is our X values, right? So what's the farthest left it gets in our X values? Looks like -4. So we know it's not B. It's not all real numbers because it's not going forever to the left, but it is going forever to the right. When a graph from the computer goes to the edge of the screen like that, you can assume that it's going forever. So we just have to figure out, is it this guy or is it this guy? Well, I will remind you that we're saying this is the X value. Are the x values, are all of our x values not getting eaten and negative 4 is getting eaten, or are all of our x values getting eaten and negative 4 is not? So is negative 4 the most or is negative 4 the least? Negative 4 is the least here. It's the farthest left, right? So that means that this eats the bigger one, right? It doesn't want the negative 4, it wants the x. So, and then the range. All right, now this one is a little bit tricky for me to explain here. Normally when I would draw this, I would draw arrows here. It might be hard to tell, but this is going to continue on very, very slowly, but it is going to continue on going down, 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 to down, down, to down. And then this way it's going to continue going up, 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 up. So if we went over this way and we kept going, it's going really, really slow. But forever is a very, very long time. And so even though it's going slow, it will eventually get to any number we want it to get to. So we can say all real numbers. All real numbers is a fancy way in math to say every number. And if you want a fancy way to write all real numbers, we write a capital R, but with a second vertical line like that. That means all real numbers. So if you ever want to look fancy, and like if you want to see like, let's see, yeah, so you can usually just write just those. People know what you mean. You don't have to do the, now mine looks dopey. But so here are some ways that people write them. Whoa, look at those. No, these are actually number systems that you know and use all the time. N, Z, and Q are just natural numbers, which is the numbers we use to count. Z is the integers, which is positives and negatives, and Q is whole numbers. These are all kind of like whole numbers. But anyway, back to our assignment. Sorry, back to our assignment. All right. Oh. The graph shows students' study times and their scores on a recent exam. These are your test scores. No, just kidding. Determine whether each of the data points given below can be added to the graph so the graph still represents a function. Oh, okay, we're trying to see, can I add any of these? Well, what I'm going to do then is I'm going to use snipping tool so I can actually draw on this. And if I was doing this like on a test or something, I would really, really actually draw on this. I thought it was Nadia, but it's Nada. Scored 97, studied for 9 hours. So 9 hours, got a 97. That's what, here? All right, so that's okay. Alex scored a 77 and studied 4.5 hours. So that's like here. Oh, wait, look at that. If I draw a vertical line there, that's no good. So we can't add Alex's and have this still be a function. Damien scored an 80 and studied for 7.5 hours. So let's see, 7.5 hours, 7.5 hours. Oh wait, that's not 4.5 hours. This is 4.5 hours. So 4.5 hours would be here. And now it's not vertical. Alex is okay. Damien, same idea, right? Here's 7 hours. So then 7.5 is like here. And you got a 77. Here's a 70. So 77 is like here. Damien's good. Pilar scored an 85. Pilar, maybe? 8 hours. Okay, so your 8 hours got an 80. Oh, okay. Here's an actual problem now, right? So can't Pilar, Pillar. If you know somebody with that name, I would love to hear how it's pronounced. All right, and then Dylan. No, Dylan. Okay. 6 hours. And you got a 90. So there's another one where no good. So you can't add Dylan. Let me see if I got it right. All right. What if there was like another person, like Francesca, and Francesca did like 9.5 hours and scored an 80. Would that be okay? So if I draw a vertical line, here's the thing, that's the same point. It's not a different point. So it's okay to have the same point there as long as it's exactly the same point. All right.
Did you add this bottle?
Our last question. A business rents bicycles for $10 an hour with a maximum daily fee of $100. Make a table that shows the cost for renting a bicycle for 1, 3, 11, and 20 hours. Is cost a function of time? Explain. Is time a function of cost? Explain. Okay, so we will talk about this. Final round. All right. I wanted to have a more challenging question that makes us go a little bit more in depth. So, all right, let's make the table. Oh wait, why would I make the table when I can copy paste the table? Wait, why am I doing that? Just use snipping tool. This thing's great. Okay. All right. So $10 an hour. Oh, so like at 1 hour it's $10. Oh, is it really this easy? Wait, is it why? Ugh. So at 1 hour it's 10. At 3 hours it's 30. You just multiply them all by. Is it really? Oh wait. It's not 11 times 10 here. It's not $110 because it says a maximum daily fee of $100. It's actually just $100 here. And then at 20 hours, still $100. So is cost a function of time? And so what this is saying is cost the y value and time is the x value? And so, or is cost our output and time is our input? And yes, cost is a function of time because each input, which is each time, corresponds to exactly one cost. And you might be confused with me saying that because there are 2 times when it costs $100. That's not a problem. The problem would be is if at 3 hours it costs $30 and then at 3 hours it costs $100. If we ever had a repeat in the time, that would be an issue. So let's see, can we say that time is a function of cost? So that's where time would be our y value and cost would be our x value, right? Our inputs. So if I input 10, I output 1. If I input 30, I output 3. If I input 100, I output 11. If I input 100, I output 20. That means time is not a function of cost because each cost corresponds to, or wait, at least one cost corresponds to more than one time. And that is all I have to say about functions today. So I forgot to start the video saying functions are going to be a little bit of a deviation from what we've been doing. Eventually we're going saying I didn't do this question. I did this question. Saying I didn't do this question. I did this question. That's weird. So if you ask for a similar question, then it's like, nope, didn't do it. Submit my work. Yay. Me got a 100% 12 out of 12. All right. So we're going to go through this. We'll have a quiz in a few days, or in a few lessons, like 1 or 2 more lessons, and then we'll review and do a quiz, and we'll just keep on going and probably finish up this chapter before the marking period's over, in all honesty. You might notice that in some ways this was easier than stuff we've been doing. So, oh, look at that picture of Maeve. All right. Well, I hope this was helpful, and I will see you later.